An ancient map shows Antarctica without its ice, centuries before its official discovery. This is the enigma of the unexpected precision of ancient global mapping systems. Our ancestors supposedly lacked the technology for such accurate charts, yet a handful of surviving documents defy this logic with coastlines and continents rendered in startling detail. By the end of this journey, you will see human history through a completely new lens, questioning the very timeline of exploration and knowledge. We will examine charts that suggest an awareness of lands unknown to their makers and theories of a lost golden age of navigation. How did they achieve this? What forgotten chapters of exploration are missing from our textbooks? What does it truly mean to be an advanced civilization? That moment of stunned disbelief is not just a story, it is a documented event. In the mid-20th century, a cartographer named Arlington Mallory was tasked with overlaying the Piri Reis map of 1513 with modern polar projection charts. The map, drawn on gazelle skin by an Ottoman admiral, famously shows a portion of the South American coastline. But when Mallory aligned it with a seismic survey map of the subglacial bedrock beneath Antarctica, the correspondence was not merely suggestive, it was eerily specific. The coastline on the ancient chart matched the landmass under the ice, a contour that had been hidden for millennia. This is the heart of our anomaly, a precise geographical truth recorded centuries before the technology existed to detect it. So what exactly makes a map unexpectedly precise? It is not about artistic flourishes or mythical sea monsters in the margins. We must establish clear, objective criteria. First, accurate longitudinal placement. Determining longitude at sea was the great unsolved puzzle of navigation until the 18th century. Yet some of these maps place continents with a longitudinal accuracy that seems to defy that historical fact. Second, correct continental shapes. The rough outline of Africa is one thing, but the distinct, recognizable bulge of Brazil or the intricate river deltas of Southeast Asia is quite another. Third, and most controversially, is the depiction of lands supposedly completely unknown to the culture that created the map. This is the depiction of Antarctica, or the full scope of the Americas, on charts from eras when, according to our textbooks, no one could have known they were there. The historian Charles Hapgood gave this mystery its modern framework. After studying the Piri Reis map and others, he proposed they were not original works of genius, but copies of copies, tracing back to much older source maps. These source maps, he argued, must have been compiled by a sophisticated, seafaring civilization in the deep past, a civilization whose accomplishments were later forgotten. Hapgood's work introduces the core debate: is this evidence of a lost chapter in human history, or simply a series of incredible cartographic coincidences? Precision in this context does not mean perfection. These maps contain errors, omissions, and distortions, as any map from any era does. The anomaly is the presence of specific, accurate geographical knowledge that appears anachronistic. It is the detailed, realistic course of the Amazon River on a map from 1519, when European exploration of that river's interior was still in its infancy. It is the subglacial topography of Queen Maud Land, Antarctica, appearing on a chart drawn over 300 years before the continent was officially discovered. This is our foundational definition, separating miraculous claims from measurable cartographic head-scratchers. How then do we objectively judge a map from a time when half the world was supposedly a blank space? The answer lies not in the ornate compass roses, but in the silent testimony of the grid lines and the ghostly coastlines we are just beginning to understand. The bustling port of Constantinople in the early 16th century was a crossroads of the known world, and in a quiet scriptorium overlooking the Golden Horn, an Ottoman admiral named Piri Reis was committing a global vision to parchment. His great world map of 1513, drawn on the skin of a gazelle, is the crown jewel of this cartographic mystery. It is not merely an artifact, it is a confession of borrowed knowledge. In his own notes on the map, Piri Reis openly states he compiled it from multiple sources, including the recent charts of Christopher Columbus and, more intriguingly, from what he called the maps of the ancients. This humble admission is the key to everything that follows. The map's rendering of the western coast of Africa is remarkably accurate for its time, a testament to active Portuguese exploration. But it is the landmass jutting from the southern edge of the chart that ignites the enduring controversy. Many researchers, most notably Professor Charles Hapgood in the 1960s, argued this land is Antarctica, specifically the Palmer Peninsula, depicted with a shocking lack of glacial ice. They point to the correspondence between the map's coastline and modern seismic surveys of the continent's subglacial bedrock, a shape hidden for millions of years. The implication is staggering that Piri Reis had access to a source map drafted in a pre-glacial era, a time when human civilization, according to conventional history, should not have existed. Of course, mainstream scholarship offers a compelling counterpoint. Many geographers and historians contend this controversial landmass is not Antarctica at all, but a distorted, duplicated representation of the eastern coast of South America, pulled southward by a common cartographic error of the period. They argue the map's known inaccuracies, like the misplaced Caribbean islands, demonstrate it was a work of synthesis and guesswork, not a precise geological survey. This balanced view is crucial. It reminds us that anomaly hunting can sometimes see patterns where none exist. Yet, even within this skeptical framework, questions linger. The map's technical construction adds another layer of intrigue. It is drawn in the Portolan style, a practical navigational format using a web of room lines radiating from central wind roses to plot constant bearing courses across the sea. This was advanced, practical maritime knowledge, but those cryptic notes mentioning Alexandrian sources whisper of something older, a lineage of learning. If the southern land is indeed a mangled South America, why did Piri Reis label it with place names suggesting a temperate climate? And why did he so carefully cite ancient authorities for a continent discovered only 2 decades prior? The map feels less like a single creation and more like a collage, a palimpsest where the faded ink of a lost world bleeds through the vellum. Admiral Piri Reis did not claim to have discovered these lands himself. He claimed to be a librarian, piecing together a global story from fragments of a much older book. To understand what that book might have contained, we must turn our gaze from the Ottoman Empire to the halls of a French king, where another map from the same enigmatic period awaits. 18 years after Piri Reis put ink to gazelle skin, another map emerged from a very different world of learning. In the scholarly circles of Paris, the mathematician Oronteus Finaeus presented a world map of 1531, drawn in an elegant cordiform or heart-shaped projection. Its depiction of the southern hemisphere is where the mystery deepens from intriguing to almost inexplicable. Unlike the ambiguous land on the Piri Reis map, Finaeus's southern continent is unmistakable. It is a massive, detailed landmass sitting squarely over the South Pole, complete with mountain ranges, river valleys, and a strikingly accurate coastline that includes the deep indentation of the Ross Sea. This is not the vague, theoretical terra australis that decorated other maps of the era, a placeholder for unknown lands. This looks like a real continent, rendered with a specificity that feels out of time. Modern cartographic analysis has subjected this map to rigorous scrutiny. When researchers, including Charles Hapgood's team, overlaid the Finaeus map with a modern polar projection of Antarctica's subglacial bedrock, the match was compelling. The general outline aligned, but more than that, specific features corresponded. the raised areas Finaeus drew as mountain ranges align with the actual transantarctic mountains, and the pronounced gulf on his map mirrors the Ross Sea's subglacial basin. The map even suggests an understanding of the continent's immense scale, showing it as larger than Europe, which is geographically correct. This level of detail pushes far beyond educated guesswork. To create such a map, a cartographer would need more than a sailor's tale of distant ice. They would need a coherent survey of the entire coastline, a feat requiring either circumnavigation or a viewpoint from high above the pole itself. The rivers and valleys drawn on the continent present another profound puzzle. Finaeus depicted an Antarctica free of its mile-thick ice cap, a landscape that has not been visible to human eyes for at least 12 million years. This suggests his source material, which he also credited as coming from the ancients, originated in a pre-glacial epoch. So we are left with a haunting question. If this map is based on genuine observation, who possessed the capability and the necessity to conduct a detailed topographic survey of Antarctica in an age when the continent was supposedly a blank space on the human mind? The tools required for such an undertaking, a method for determining precise longitude, advanced mathematics for spherical projection, and ships capable of polar exploration were all centuries away from their documented invention. The Oronteus Finaeus Map stands as a silent, detailed affidavit, testifying to a geography that should have been impossible to know. It forces us to confront a gap in our historical record, a period of exploration so complete its maps survived as copies, while the civilization that made them vanished into the fog of time. To understand how such knowledge could be transmitted, we must examine the very mechanics of ancient mapmaking, the hidden code within the lines and scales that may hold the secret to their unexpected precision. The intricate web of lines on a Portolan chart is not decoration, it is a functional machine for navigation. While the Piri, Reis and Finaeus maps hint at lost global knowledge, the Portolan charts of the medieval Mediterranean offer us something different, a masterclass in achievable empirical precision. Emerging in the 13th century, these were working documents for captains, drawn on vellum with a stark, practical beauty. Their coastlines of the Mediterranean and Black Sea are not vaguely suggestive. They are often accurate to within a few miles, a feat accomplished 300 years before the marine chronometer solved the longitude problem. This was not magic, but a triumph of accumulated human experience. Maritime historians describe their creation as a bathymetric process, meaning it was built from the sea up. Imagine generations of pilots, their hands gripping the tiller, meticulously recording every headland, every bay, every shift in the seabed in handwritten logbooks known as portolanos. These were compendiums of course directions, sailing times, and coastal landmarks. Over decades, this collective memory was synthesized, cross-referenced, and finally translated into the visual language of the chart. The iconic room lines radiating from multiple compass roses were not for artistic symmetry, they were a practical tool. A navigator would lay a straight edge from his known position to his destination along one of these constant bearing lines, then simply follow that compass heading across the open water. It was a system born from necessity and refined through relentless repetition. The precision of these charts proves something profound, that a pre-technological society could achieve cartographic excellence through meticulous observation and the slow, collaborative building of knowledge. They stand as a high watermark of practical, empirical science, a testament to what can be accomplished when countless individual journeys are woven into a single, coherent map. Yet, this very success raises a more difficult question for our global anomalies. The Portolans worked because they covered a confined, well-traveled sea where navigators could rely on known landmarks and short voyages. The knowledge was regional, cumulative, and verifiable within a single human lifetime. This makes the leap to a purported world map depicting continents separated by vast, uncharted oceans fundamentally different in kind, not just in scale. If medieval sailors could map their own sea with such fidelity through patient observation, what would it take to map the entire world? The Portolan phenomenon gives us a benchmark for genuine, hard-won precision, and in doing so, it sharpens the mystery of the maps that seem to leap over that benchmark entirely. But if the Portolans show us what dedicated, regional observation can achieve, how do we explain a map of the entire world? This question leads us directly to one of the most provocative ideas in alternative history, the concept of a lost source civilization. The scholar who gave this theory its modern voice was a university professor named Charles Hapgood. In the 1960s, after years of studying the Piri, Reis, Oronteus Finaeus, and other anomalous maps, Hapgood published a book titled Maps of the Ancient Sea Kings. His conclusion was as simple as it was revolutionary. He argued these maps could not be products of the cultures that physically drew them. Instead, he saw them as copies, surviving fragments of a much older and far more sophisticated global cartographic tradition. Hapgood proposed that a highly advanced seafaring civilization thrived thousands of years before recorded history, perhaps during the last ice age. This civilization, he suggested, possessed a sophisticated understanding of astronomy, mathematics, and spherical trigonometry, allowing them to chart the world with a precision that would not be matched until the modern era. Their knowledge, preserved on scrolls or tablets, was supposedly rescued from the great library of Alexandria before its destruction, or passed down through cultures renowned for their maritime skills, like the Minoans or the Phoenicians. These later societies became the custodians of this fading wisdom, copying the maps without fully understanding their scientific basis, which is why later versions contain both stunning accuracy and curious errors. Hapgood's technical analysis formed the core of his argument. He performed a process called coordinate translation, taking points from the ancient maps and mathematically transferring them onto a modern grid. His findings suggested the original source maps were compiled using a form of spherical trigonometry and an accurate determination of longitude, concepts officially developed millennia later. He believed the maps used a projection centered not in the Mediterranean, but somewhere in ancient Egypt, hinting at the possible origin point of this primordial knowledge. The emotional pull of Hapgood's hypothesis is powerful. It paints a picture of a golden age of exploration, a global network of exchange that was catastrophically interrupted, perhaps by the rapid sea level rise at the end of the last glacial period. This idea forces a profound reconsideration of human progress, suggesting our history is not a straight line from primitive to advanced, but a cycle with forgotten peaks. Yet, for all its imaginative appeal, the hypothesis faces a formidable wall of critique from mainstream archaeology and history. Experts point to the conspicuous and total absence of physical evidence. An advanced, globe-spanning civilization would have left behind more than just cryptic lines on a map. Where are their cities, their tools, their trash heaps, their ports? The archaeological record shows a gradual, traceable development of human society, with no sudden insertion of a technologically sophisticated culture capable of global navigation. Skeptics argue that the maps Hapgood studied can be explained through a combination of known exploration, clever guesswork, cartographic errors, and the persistent human tendency to fill blank spaces on a map with speculative lands. They see the alignment with subglacial features as interesting coincidences magnified by selective interpretation. This balanced perspective is essential. It reminds us that a compelling story is not the same as proven fact. The value of Hapgood's work may not lie in proving the existence of Atlantis, but in highlighting a genuine and persistent anomaly. He asked a question that still echoes: if these maps are not copies of something older, then what combination of skill, luck, and lost records produced such unexpected glimpses of the world? To move from theory to a tangible object, we must examine a chart that seems to embody this very mystery of transmission, a map that connects the age of discovery with a world that should not have been known. The dusty study of a Renaissance scholar holds another key to our puzzle. Surrounded by crackling parchments, travelogues from returning sailors, and fragments of classical geography, a cartographer was not just a draftsman but a master synthesizer. His task was to weave together countless threads of second-hand information, rumors, and half-remembered coastlines into a single, plausible image of the world. This process of scholarly synthesis offers a powerful, less sensational explanation for the maps we find so baffling. Historians of cartography, like John Bryan Harley, remind us that every map is a social construction, a collage of information filtered through the beliefs, biases, and available data of its time. Imagine the flow of knowledge in the early 16th century, a torrent of new reports flooding into European ports. Portuguese caravels brought charts of the African coast. Spanish galleons returned with tales and crude sketches of the New World. Arab traders who had for centuries navigated the Indian Ocean shared knowledge of the Indies. Norse sagas, though centuries old, contained descriptions of icy lands to the far northwest. A dedicated compiler in Paris or Istanbul could have access to this dizzying array of fragments. Through meticulous cross-referencing and educated guesswork, could they have accidentally stitched together a representation of the world that appears to see ONTAI Chinese letter knowledge? This slow drip theory of cartographic development suggests that our seemingly anomalous maps are not snapshots of lost science, but the impressive result of a global, if fragmented, information network finally coming together. A map like that of Oronteus Finaeus could then be seen as a brilliant, yet ultimately speculative, synthesis. The southern continent on his chart might not be a memory of ice-free Antarctica, but a conflation of many reports. Descriptions of the frozen north from Norse accounts, tales of mountainous terrains from southern voyages, and the ancient philosophical belief in a necessary counterweight continent, Terra Australis, could have merged in the cartographer's mind. A single, lucky guess about a coastline's shape, or the distortion that occurs when transferring a curved Earth to a flat sheet, might later appear to eerily match a reality we only now understand. This process explains many of the errors and oddities on these old charts, like the misplaced islands or distorted sizes, as the natural growing pains of a world picture being assembled from scattered pieces. Yet, even this reasonable theory strains against certain details. Can synthesis alone account for the specific subglacial topography that seems to match on some of these maps? Could the confluence of sailors' yarns and classical myth accidentally produce the correct longitudinal relationship between continents, a mathematical problem that stumped the greatest minds for generations? The scholarly synthesis argument is compelling and likely explains a great deal, but it leaves a nagging residue of questions, a sense that some elements of precision are too specific to be born from rumor. To move from the realm of compiled reports into the realm of measurable geometry, we must look past the coastlines and examine the silent, mathematical skeleton of the map itself, the grid of latitude and longitude that may hold the most definitive clue. A ship wallows in the blackness of an open ocean, its captain clutching a compass as waves crash over the deck. He knows his latitude, his north-south position, by the angle of the North Star. But his east-west location, his longitude, is a terrifying mystery. In this vast, featureless expanse, being just 1 degree of longitude off course could mean missing a vital island by 60 nautical miles, a mistake that could doom the entire crew. This was not just a navigational headache, it was the single greatest technical obstacle to creating an accurate world map until well into the modern era. The problem is deceptively simple. The Earth rotates 360 degrees every 24 hours. This means that for every hour of time difference between your current location and a known reference point, you are 15 degrees of longitude apart. To know your longitude, you must know exactly what time it is at that reference point, while simultaneously knowing the precise local time where you stand. On land, this could be managed with careful astronomical observation, but at sea, on a rocking ship, without a clock that could keep perfect time for weeks or months on end, the solution remained utterly out of reach for centuries. So critical was this problem that in 1714, the British government established the Board of Longitude and offered a prize equivalent to millions in today's currency for a practical method. The eventual winner was a clockmaker named John Harrison, who spent his life building a series of revolutionary marine chronometers. This historical context makes the precision on some ancient charts all the more bewildering. If the finest minds of the 18th century struggled to solve longitude, how could any civilization before them possibly place continents with apparent longitudinal accuracy? Could there have been an ancient, forgotten workaround? Some researchers point to a method known to classical astronomers like Hipparchus, using lunar eclipses as a universal clock. During a total lunar eclipse, the moon enters the Earth's shadow at the same absolute moment for every observer on the night side of the planet. By recording the local time when the eclipse began or ended, and comparing it to the time recorded at a known reference location, like Alexandria, one could calculate the longitudinal difference between the two places. In theory, a network of learned observers across the ancient world, all recording the same celestial event, could have produced a sparse but valuable web of longitudinal data points. This was not a method for a sailor at sea, but for a scholar in a fixed observatory. It was painstaking, relying on rare events and precise timekeeping using water clocks or astrolabes, and the resulting calculations would have been complex. The margin for error was significant, perhaps several degrees, but it was a method grounded in known ancient science. Could such sporadic, astronomically derived points have been the skeleton for a world map? It is a tantalizing possibility. Imagine a library in Alexandria compiling reports from Babylon, Greece, and perhaps even distant trading posts after a major eclipse. Over centuries, these occasional snapshots might have slowly built up a rough, patchy understanding of the world's east-west dimensions. This would not explain the coastal details of Antarctica, but it could offer a pathway for how the general longitudinal placement of continents might have been approximated long before Harrison's clock. It suggests that precision of a certain kind might not have required futuristic technology, but instead an organized, long-term project of celestial observation and scholarly cooperation on a scale we rarely attribute to the ancient world. Yet this door, while open, leads to another set of profound questions. Who organized such a project? What civilization had the reach, the motivation, and the scholarly continuity to compile this data over generations? And if they did, why is the magnificent world map that resulted only glimpsed in fragments, copied by later hands who no longer understood its origins? To find a possible answer, we must look beyond the mechanics of timekeeping and consider the very shape of the Earth itself, and the sophisticated mathematics required to flatten a sphere onto parchment. The stars did not merely decorate the night sky for our ancestors, they were a vast, rotating clock and a fixed grid of reference points. While a sailor might struggle with longitude on a heaving deck, an astronomer in a temple or observatory faced no such instability. The real key to the mapping mystery may lie not in forgotten voyages, but in the profound, demonstrable mastery of the heavens achieved by cultures across the globe. Ancient Babylonian clay tablets record precise mathematical predictions of lunar eclipses. The Maya calculated the length of a solar year to a more accurate degree than the Gregorian calendar that would follow them. Chinese imperial astronomers maintained meticulous records of celestial events for millennia. This was not stargazing, it was a rigorous mathematical science. Scholars of archaeoastronomy like Clive Ruggles show us how this knowledge provided something invaluable, a stable, universal coordinate system, the celestial sphere itself. If you can predict exactly where a star will rise or set on a given night from any fixed location on Earth, you have a tool for anchoring that location in a global framework. The path of the sun, marked by the solstices and equinoxes, gives you an exact east-west line, a true meridian. The altitude of the North Star or its southern counterpart gives you your latitude. By using the stars as fixed markers, an ancient astronomer could theoretically determine the position of any terrestrial point relative to any other, provided they could share data. This suggests the intellectual architecture for a world map, a mathematical skeleton of latitude and longitude, existed in the minds of ancient scholars long before any ship could possibly verify the shapes that would fill it in. Consider the simple, powerful concept of key latitudes. An observer could note that at a specific latitude, say that of the Egyptian city of Thebes, the sun passed directly overhead at noon on the summer solstice. Any other place on Earth where that same phenomenon occurred was, by definition, on the same latitude line. By linking such astronomically defined points across continents, a theoretical network of positions could be charted. This process would not reveal coastlines, but it could create a scaffold of known points. The slow, grand cycle of the precession of the equinoxes, understood by Hipparchus in ancient Greece, further proves these cultures were thinking in vast scales of time, observing changes in the sky that unfold over 26,000 years. If they could model celestial mechanics on such an epic scale, is it so unthinkable that they might attempt to project that order onto the Earth itself? The Polynesian voyages provide the most stunning practical example of this celestial cartography. Without compass or chart, they navigated the Pacific Ocean by memorizing the zenith stars, the specific stars that passed directly over each of their known islands. By reading this living star map, they could sail for thousands of miles and know, by the night sky alone, when they had reached the latitude of their destination. This proves a culture could use the heavens to navigate to a precise terrestrial point they already knew. The deeper question our mystery poses is the inverse. Could a culture have used the heavens to mathematically deduce the existence and rough position of a terrestrial point they did not know? If ancient astronomers from different continents shared their celestial observations, comparing the altitude of the same star from Babylon, from Egypt, and from a distant trading post in a far-off land, they could triangulate that post's position on the globe. Slowly, a ghostly outline of the world's landmasses might emerge from the geometry of the stars, long before any single explorer had walked its full perimeter. This celestial framework does not gift us a finished map of Antarctica, but it provides a credible, sophisticated pathway for how the bones of a world map could have been assembled through intellect, not just exploration. It transforms the mystery from one of impossible travel to one of potentially lost collaboration, a forgotten project of global astronomy whose records, like so much ancient knowledge, may have survived only as cryptic traces in later copies. To see how this celestial knowledge might have been physically preserved and transmitted, we must examine the maps that are not maps at all, but intricate machines of metal and stone. The silent testimony of the stars finds its echo in the thunder of silk sails. While scholars in the West debated the shape of the world, a fleet of unimaginable scale was actively charting it. In the early 15th century, the Ming dynasty's treasure ships, commanded by the eunuch Admiral Zheng He, were the largest wooden vessels ever built, floating cities that dominated the Indian Ocean. Their voyages were not mere expeditions but state-sponsored displays of power and diplomacy, backed by a cartographic system of breathtaking detail and accuracy. This is the world of the Malkun map, a document that shows us the absolute zenith of what was possible when a civilization turned its full resources toward understanding the globe. These were not speculative charts filled with sea monsters. The Multidisciplinary Map, part of a larger treatise, is a practical navigator's guide. It meticulously details the coastlines of Southeast Asia, India, the Arabian Peninsula, and the eastern coast of Africa down to modern-day Kenya. The precision comes from direct, repeated experience, compiled from the logs of 7 epic voyages between 1405 and 1433. The map is annotated with sailing directions, notes on currents, depths, and landmarks, transforming geography into a repeatable journey. Experts in maritime history point out that this was a synthesis of knowledge streams, integrating Chinese astronomical observation with the hard-won experience of Arab and Indian ocean pilots who had plied these waters for centuries. It was a comprehensive working system for navigating a known world. This represents a critical distinction in our mystery. The Multidisciplinary maps are not anomalously precise, they are brilliantly, explicably precise. They show us the high watermark of systematic, empirical charting before the European age of discovery. They prove what a coordinated, well-funded, and meticulously recorded exploration program could achieve, mapping thousands of miles of coastline with a consistency that puts many contemporary European portolans to shame. Their existence forces a fascinating parallel question. If the Chinese could map the world from the east with such fidelity, and if their voyages reached the very doorstep of Africa, what happened to all that knowledge? After the final voyage, the Ming dynasty turned inward. The great ships were left to rot, and the records were largely archived or lost. But ideas, especially valuable ones like accurate maps of lucrative trade routes, have a stubborn way of traveling. This is where our threads may intertwine. The last of Zheng He's voyages concluded in 1433. 80 years later, in Constantinople, Piri Reis compiled his map, citing sources that included Arab and ancient charts. The Indian Ocean and the coast of Africa were regions where Chinese, Arab, and later Portuguese knowledge overlapped. Is it possible, through the vibrant trade networks of the Indian Ocean and the scholarly hubs of the Islamic world, that fragments of Chinese cartographic data filtered westward? Could a sketch of the African coast, derived from a Chinese sailing manual, have found its way into the collection of an Ottoman admiral, becoming one of those many source maps he so humbly credited? We have no smoking gun, no document that directly proves this transfer, but the possibility hangs in the air, a tantalizing thread in our tapestry of global knowledge. It suggests that the unexpected precision we see might not always stem from a single lost civilization, but sometimes from the forgotten connections between great civilizations, a slow, hidden osmosis of information across Eurasia. The Treasure Fleet maps stand as a monument to what was openly known and systematically recorded, challenging us to wonder what else might have been shared and then forgotten in the vast spaces between empires. Within the great library of Alexandria, a different kind of map was being drawn, not on vellum for a ship's captain, but in the mind of a scholar. Claudius Ptolemy's Geographia, compiled in the 2nd century, was a work of breathtaking theoretical ambition. It presented the entire known world from the Canary Islands to the Malay Peninsula, not as a picture, but as a mathematical list of coordinates. Ptolemy gave every city, every river mouth, every mountain range a specific latitude and longitude, plotting them on a grid that covered a spherical Earth. This was the ultimate act of intellectual cartography, an attempt to cage the chaotic reality of geography within the pure, ordered lines of geometry. His system was revolutionary, a framework that would define the very goal of mapmaking for over a millennium. Yet its brilliance was shadowed by a critical flaw. Ptolemy's calculations were based on the best available reports from travelers and earlier geographers, but this data was often vague, exaggerated, or simply wrong. Most consequentially, he accepted an estimate of the Earth's circumference that was about 1/4 too small. This single error collapsed the world, distorting his entire coordinate system. On a Ptolemaic map, the Indian Ocean becomes a landlocked sea, with a vast, unknown southern continent curling up to connect Africa to Asia. Europe is stretched eastward, and the distance from Spain to China appears deceptively short, a miscalculation that would centuries later fill the heart of a Genoese sailor named Columbus with a dangerous yet world-changing hope. Expert historians of cartography note the profound irony of Ptolemy's legacy. His work, lost to Western Europe after the fall of Rome and rediscovered during the Renaissance, was both a catalyst and a cage. It provided medieval scholars with the sophisticated concept of a coordinate grid, reigniting the dream of a mathematically precise world map. But it also handed down a world shrunk and misshapen by ancient errors. For generations, cartographers struggled to reconcile the authoritative, theoretical perfection of Ptolemy's system with the new, contradictory reports arriving from actual voyages. This tension reveals the core of our mystery with stunning clarity. Here was the dominant, scholarly model of the world, endorsed by ancient authority, yet it produced maps that were often less accurate, less practically useful than the working charts of Mediterranean sailors. The Portolan charts with their empirically correct coastlines, and even the Piri Reis map with its intriguing southern land, seemed to operate outside Ptolemy's distorted framework. They did not slavishly follow his shrunken Earth or his enclosed Indian Ocean. Their precision, such as it was, appeared to come from a different source entirely, not from theory and calculation, but from experience and observation. This presents us with two parallel streams of knowledge flowing through history. One was top-down, born in the library, seeking to impose order from above through mathematics and inherited text. The other was bottom-up, born on the deck of a ship, built from the painstaking accumulation of bearings, soundings, and landmarks. For centuries, these streams barely mingled. The scholar with his Ptolemaic manuscript and the sailor with his stained Portolan chart inhabited different intellectual worlds. How then did the profound truths from the sailor's world, the truths that sometimes seem to defy history itself, ever find their way onto parchment? The answer lies not in a grand library, but in the calloused hands of the men who sailed by the stars and remembered every curve of the coast. A single line of text on a faded parchment ignited a historical firestorm in 1965. The Vinland map, unveiled to the world with great fanfare, appeared to be a stunning medieval confirmation of Norse voyages to the New World. In a corner of the chart, west of Greenland, a rough outline of a landmass was labeled in Latin, Island of Vinland. If authentic, this map, drawn around 1440, decades before Columbus sailed, would have been the earliest known cartographic depiction of any part of the Americas. It was precisely the kind of document that could rewrite our understanding of discovery, a tantalizing piece of evidence that seemed to validate the sagas of Leif Erikson. The initial analysis was promising. Handwriting experts declared the script consistent with a 15th century style. The parchment itself was dated to the correct era. Even the ink, under early examination, seemed to be an iron gall formulation typical of medieval manuscripts. For a moment, it looked like a miraculous discovery, a direct link from the world of Norse explorers to the libraries of the Renaissance. Yet the true story of the Vinland map is not one of validation, but of rigorous, escalating doubt. It became a forensic battlefield, a case study in how modern science dissects a historical claim. As the map was subjected to more advanced testing, anomalies emerged. The most damning evidence came from a powerful tool called particle analysis. Scientists discovered that the ink contained microscopic crystals of a compound called anatase titanium dioxide, a specific, synthetic form of titanium white pigment. This substance was not produced in a pure, crystalline form until the 1920s. Its presence was like finding a microchip sewn into the lining of a doublet, a clear chemical signature of the 20th century. Historians and chemists worked in tandem, their collaboration revealing the forger's likely method. someone had skillfully acquired a genuine, blank medieval parchment, possibly from a damaged book. They then carefully drafted the map using a modern ink formulated to mimic the appearance of aged iron gall. The forger was clever, but they could not anticipate the analytical techniques of a future they would never see. The scholarly consensus now views the Vinland map as an elaborate mid-20th century creation, likely intended to deceive collectors and rewrite history for profit or fame. This episode is far from a dry academic footnote. It is a vital lesson in healthy skepticism. It teaches us that the allure of a world-changing artifact can be powerful, but it must be tempered by relentless, multi-layered scrutiny. The map reminds us that provenance, the documented history of an object's ownership, is as important as the object itself. It underscores that a single line of scientific evidence, like the Anomaly crystals, can unravel the most compelling narrative. The Vinland map controversy does not discredit the genuine mystery of the other charts we have explored. Instead, it provides a crucial filter. It forces us to ask tougher questions of the Piri, Reis, and Oronteus Finaeus maps. What is their unbroken chain of custody? Have they undergone the same battery of chemical and physical tests? The answer is that many of these maps have, and while they contain errors and mysteries, no smoking gun of modern forgery like Anomaly has been found. This journey, then, is not about accepting every anomaly at face value. It is about learning to distinguish between a clever fake and a genuine, unresolved puzzle. The Vinland map is the shadow that makes the light of other mysteries more intriguing, precisely because they have, so far, survived the same intense glare of scientific inquiry. The forger's clever ink leaves us with a vital question: how do we separate inspired guesswork from genuine memory? A century before the Vinland map hoax, a respected French geographer named Philippe Buache presented a theory that would later become entangled in this very debate. In 1737, Buache published a world map featuring a detailed southern continent, but his approach was not that of a navigator or a copier of ancient manuscripts. He was a man of the Enlightenment, a theorist who believed the Earth's landmasses followed elegant, symmetrical patterns. Observing that major rivers in known continents often flowed from central mountain ranges toward opposite coasts, Buache proposed a grand geographical rule. He reasoned that a vast southern continent must exist to balance the northern lands, and that it too would be shaped by this logic of symmetrical drainage. His map therefore showed not a blank terra incognita, but a meticulously hypothesized land, complete with mountain chains and river basins flowing inward to a central sea. This was cartography as intellectual exercise, an attempt to predict geography through principle rather than to record it from observation. The resulting image of Antarctica is strikingly specific. It depicts two large landmasses separated by a wide channel of water. To modern eyes, this can look uncannily like the actual division between East and West Antarctica, separated by the vast, icy trench of the Transantarctic Mountains. It is this visual echo that has led many anomaly researchers to suggest Buache must have had access to some lost source showing the continent before the ice cap formed. They point to the map's confident detail as evidence of pre-glacial knowledge passed down through the ages. Yet, scholars of historical geography offer a compelling and far more grounded explanation. Buache was working squarely within the scientific paradigms of his time. The concept of continental symmetry was a popular theoretical tool, and the idea of a great southern land was a geographical tradition dating back to ancient Greece. His map was a hypothesis rendered in ink, a best guess based on applying terrestrial rules to an unknown space. It was not a record of a past survey, but a prediction of what a future survey might find. The fact that parts of his prediction bear a rough resemblance to reality is a testament to the power of logical extrapolation, not to the possession of secret charts. This distinction is absolutely crucial for our investigation. The Buache map represents a category of false positive, where sophisticated theoretical modeling produces an image that later appears prophetically accurate. It reminds us that coincidence, when viewed through the lens of a compelling narrative, can be mistaken for evidence. Disentangling these threads requires us to look beyond the single compelling image and into the mapmaker's own mind, his published theories, and the intellectual climate that shaped him. Buache was transparent about his methods. He was building a model, not copying a relic. His work challenges us to apply the same rigor to every anomalous chart, to ask not only what it shows, but why the person who drew it believed it to be true. Was their confidence born from holding an ancient parchment, or from the elegant certainty of their own reasoning? A fog of legend shrouds the icy waters of the North Atlantic. In 1558, a descendant of a noble Venetian family named Niccolo Zeno published a map and a narrative that would baffle historians for centuries. He claimed it was based on letters and charts from his ancestors, the brothers Niccolo and Antonio Zeno, who had allegedly sailed into the northern seas in the late 1390s, decades before Columbus. The map they supposedly inspired is a cartographic ghost story populated with islands that do not exist. A large, detailed landmass labeled Friesland sits prominently south of Iceland. Another, called Icaria, floats in the Western Ocean. To the modern eye, it looks like pure fantasy. Yet, expert historians of exploration see something more complex in this enigmatic document. They suggest the Zeno map is not a simple hoax, but a deeply confused compilation, a Mediterranean scholar's attempt to make sense of second-hand reports from a world utterly alien to him. The brothers' account tells of serving a prince named Zichmni in a northern land, battling storms and encountering strange peoples. Many scholars believe Zichmni is a garbled reference to Henry Sinclair, a Scottish noble with possible connections to the Orkney Islands and, through Norse sagas, to knowledge of the North Atlantic. This is where the map's potential kernel of truth emerges. While Friesland as drawn is fictional, its description and placement seem to conflate several real locations, perhaps the Faroe Islands, a missighted section of Greenland, or even the shallow fishing banks known as the Isle of Brassel on other charts. The map's depiction of Greenland, though misshapen, shows a landmass with a distinctive eastern coastline that bears a passing resemblance to reality, a detail unlikely to be pure invention in 1558. Most telling is its notation of a fiery mountain on the island of Iceland, a clear reference to the volcanic activity of Mount Hekla. This was accurate, obscure knowledge for a Venetian with no direct experience of the far north. So what are we looking at? The leading theory among maritime historians is that the Zeno brothers, or someone they encountered, did have access to genuine Norse sailing lore. The Norse had been navigating these waters for centuries, reaching Greenland and establishing a settlement that lasted for hundreds of years. Their knowledge, passed down orally and in sagas, included practical details about currents, landmarks, and hazards. A Venetian trader or adventurer could have collected these stories, perhaps in the ports of England or Scotland, and combined them with existing speculative maps of the Atlantic. The resulting document is a palimpsest of misunderstanding. Real Norse waypoints became solidified as fictional islands. Distances were guessed, names were misheard and misspelled. The Zeno map, therefore, stands as a perfect case study in the messy transmission of geographical knowledge. It is not a precise relic of a lost civilization, but a snapshot of the foggy, error-prone process by which one culture's hard-won experience becomes another culture's confused legend. It shows us how a map can be both profoundly wrong and contain startlingly accurate data all at once. This forces a bigger question about our global puzzle. If the Norse knowledge of the North Atlantic could filter southward and get distorted into the Zeno map, what other fragments of exploration from other corners of the world might have followed similar hidden paths into the cartographic record? leaving behind only cryptic shapes and names we no longer understand. The Zeno map reveals how knowledge could travel and distort, but what if a culture existed not at the edge of the information flow, but at its very center? In the great Topkapi Palace of Constantinople, the Ottoman Empire was not just a military power, it was a living library of the world. By 1559, the empire straddled 3 continents, its ports buzzing with Venetian merchants, Arab scholars, and refugees from a fractured Spain. It was here that a cartographer named Hadji Ahmed crafted a world map of startling ambition, drawn in a graceful oval projection that seems to cradle the earth. This is not the work of an isolated guesswork, but of a civilization perfectly positioned to listen to the whispers of the entire globe. The most striking feature of Hadji Ahmed's map is its treatment of the New World. For a document created in Istanbul, the western coastline of the Americas is rendered with a detail and elongation that feels almost prophetic. It shows a recognizable contour running from a narrow, pointed land in the north, suggestive of Alaska, all the way down to a sharply defined southern tip that mirrors the reality of Cape Horn in Chile. This is not the blobby, uncertain landmass seen on many contemporary European maps. It is a deliberate, confident outline. How could an Ottoman cartographer, whose empire had no colonies across the Atlantic, achieve such a representation? The answer lies in the empire's role as the ultimate clearinghouse for information. Ottoman agents were keenly interested in the discoveries of their Spanish and Portuguese rivals. Captured ships yielded not just cargo but also charts and logs. Diplomatic channels and a thriving spy network funneled reports back to Constantinople. Jewish scholars fleeing the Inquisition in Iberia brought with them cutting-edge geographical knowledge. Hadji Ahmed was almost certainly synthesizing these captured, traded, and gifted fragments of data. His map is a mosaic, piecing together Portuguese charts of Brazil, Spanish reports from the Pacific coast after Balboa's crossing, and perhaps even earlier, now lost, sketches from the first circumnavigations. This was not magic or inherited ancient wisdom. It was espionage and synthesis operating at the highest level. The Ottoman cartographic tradition itself was uniquely suited to this task. It stood at the crossroads of the Portolan practicality of the Mediterranean, the celestial mathematics of the Islamic world, and the new flood of data from the Atlantic. A mapmaker in Istanbul could look east to the detailed Chinese-influenced charts of the Indian Ocean, west to the latest Portuguese portolans, and north to the Byzantine and Italian traditions. His workshop was a fusion reactor for geographic ideas. The precision on display, then, is a testament to the competitive frenzy of the 16th century itself. In a race where knowing a coastline could mean controlling the spice trade or claiming a continent, knowledge became the ultimate currency. States hoarded it, stole it, and selectively shared it. Hadji Ahmed's map is a snapshot of that global intelligence race, a document proving that by the mid-1500s, the rough shape of the Americas was an open secret among the learned elites of the Mediterranean world, even if the general public remained in the dark. This shifts our perspective powerfully. It suggests that some of the unexpected precision we marvel at may not require a lost civilization, but simply a forgotten network, a moment in history when all the puzzle pieces were momentarily held in one place by an empire that knew how to listen to the world. The parchment lies flat, but the world it must capture is a sphere. This is the silent, mathematical heart of every map ever drawn, the inescapable problem of projection. To translate the curved skin of the Earth onto a flat sheet, you must stretch, compress, or tear its true geometry. The method you choose dictates what kind of truth your map can tell. A projection that perfectly preserves land area will wildly distort shapes, turning Greenland into a continent-sized giant. A projection that keeps compass bearings true, essential for a sailor, will twist continents into unfamiliar forms at the poles. This is not a minor technicality, it is the fundamental cartographic dilemma, and how an ancient mapmaker solved it speaks volumes about their knowledge. Look closely at a medieval Portolan chart of the Mediterranean. Its web of room lines, those straight paths for constant compass courses, works with startling practicality. For a sailor navigating a relatively small, enclosed sea, this system is flawless. Experts in the history of cartography note that this effectiveness suggests the Portolans were constructed using a simple, local projection often called a plane chart. It treats a small section of the Earth's surface as if it were flat, a reasonable approximation over a few hundred miles. The angles between ports are preserved, making the chart a perfect tool for its purpose. But this local success raises a deeper question. Could such an intuitive geometric technique have been scaled up? If a culture understood how to project a small sea accurately, did they possess the mathematical framework to apply that logic to a hemisphere or even the entire globe? Some of the more anomalous world maps we have examined do not show the catastrophic distortions we would expect from blindly copying a coastline onto a flat grid. Their continents, while misplaced, often retain recognizable shapes and proportional relationships. This hints at something beyond luck. It suggests the original source compilers may have employed a form of spherical trigonometry, a way of mathematically translating points on a sphere onto a plane. The Mercator projection, developed in the 16th century, is the most famous example of a conformal map, one that preserves angles at the expense of size. Its creation required a sophisticated grasp of logarithmic calculus, yet the Portolans, centuries older, achieve a similar conformal property for their limited region. How one compelling theory points to a process of geometric construction rather than complex calculation. Imagine a master navigator with a compass and a straightedge, not in a study but on a sandy beach. By using a series of triangulations from known points, building a network of triangles across the sea, and then carefully transferring those angles onto a flat sheet, a skilled practitioner could create a functionally conformal chart through sheer geometric intuition and relentless iteration. This would be a craft passed down through generations of pilots, a trade secret of staggering value. The unexpected precision we see on some ancient world maps could then be the fragmented legacy of this craft applied to a grander canvas. Perhaps the original surveyors did not use equations, but instead used the stars themselves as fixed points in the sky, and through careful observation of celestial angles from different locations, they built a spherical coordinate system by hand, point by painstaking point. Their projection would not be mathematically pure in the modern sense, but it could be empirically effective, born from centuries of watching the heavens turn and connecting those movements to the landmarks below. This brings the mystery out of the realm of lost superscience and into the realm of possible, if forgotten, human ingenuity. It suggests that the boundary between intuitive craft and formal mathematics is blurrier than we think. A culture that could predict eclipses and track the precession of the equinoxes certainly possessed the conceptual understanding of a spherical cosmos. Is it so great a leap to apply that understanding to the sphere beneath their feet, flattening it not with perfect formulas, but with a brilliant, practiced workaround? The ghost in the machine of these old charts may not be a computer, but a compass, a protractor, and a mind that saw the geometry of the world in the patterns of the stars. The geometry of the stars found its ultimate expression not on parchment, but in the memory of a single human mind, standing alone on the deck of a canoe. For the Polynesian navigators, the Pacific Ocean was not a blank space to be feared, but a known and named pathway, a living map written in the language of nature itself. These voyagers accomplished one of humanity's greatest feats of exploration, settling islands scattered across millions of square miles of open ocean, all without a compass, a sextant, or a single physical chart. Their precision did not come from ink and vellum, but from an oral tradition so rigorous it formed a perfect, unwritten atlas of the sea. A master navigator, or PWO, held in his mind a celestial map. He knew the precise star that would pass directly over each destination island, its zenith star. He knew the seasonal patterns of migratory birds whose flight paths pointed toward unseen land. He could read the subtle, deep ocean swells, feeling their refraction around distant atolls through the hull of his vessel, and interpret the specific color of the clouds that gathered over lagoons dozens of miles away. This was a dynamic, experiential cartography, updated in real time with every sense. Anthropologists who have studied these traditions describe them as a symphony of environmental data, a cognitive science passed from mentor to apprentice through years of sacred, secretive training. The so-called stick charts of the Marshall Islands offer a tangible glimpse of this mental model. These intricate frameworks of palm ribs and shells were not carried on voyages. They were teaching tools constructed to represent the complex interference patterns of ocean swells around islands, an abstract, wave-based map of the archipelago. To an outsider, they look like abstract art. To an initiate, they encoded the precise feel of the sea. This system proves, beyond any doubt, that high-precision global knowledge can exist, thrive, and be transmitted across generations without a single written word. It represents a fundamentally different kind of accuracy, one that is relational, embodied, and woven into the very fabric of a culture's identity and survival. This realization forces a profound shift in our search for the source of anomalous maps. We have been looking for lost libraries, for scrolls copied and recopied. But what if some of the precise coastlines that startle us on ancient parchment began not as a survey, but as a song? What if a Greek or Phoenician trader centuries ago sat with a Polynesian-like navigator from a now-vanished coastal culture and listened, utterly captivated, as the sailor described from memory the shape of a distant land? The storyteller might have used his hands to trace a coastline in the sand, pointed to stars to indicate its bearing, described the taste of the river silt or the cry of the coastal birds. The listener, a literate man, might have done his best to translate that living, sensory knowledge into the static symbols of his own cartographic tradition. In that translation, the dynamic truth of the oral map would become fixed, and perhaps some of its stunning accuracy would remain, like a fossilized impression. The mind itself, trained by a great tradition, is a precision instrument. The Polynesian example does not solve the riddle of the Piri Reis map, but it completely redefines the playing field. It shows us that the human capacity to know the world with exacting detail predates writing, and that some of the most sophisticated mapping systems in history left no physical trace at all, except for the people who found their way home. The line between a measured coastline and a mythical kingdom was once beautifully blurred. Medieval and Renaissance maps are often crowded with more than just cities and rivers. They feature roaring sea serpents in uncharted waters, the elusive realm of the Christian king Prester John in the east, and islands of pure gold waiting for a brave explorer. These were not mere decorations for the gullible, they were integral to the map's purpose, reflecting a world view where physical geography and spiritual belief occupied the same space. To understand the maps of the past, we must first understand that they were often as much declarations of faith and philosophy as they were tools for navigation. A cartographer's duty was not only to plot what was known, but to illustrate what must be, according to the wisdom of the ancients and the logic of the divine. This fusion of fact and fantasy creates one of the greatest challenges in our search for unexpected precision, because sometimes a map can appear startlingly accurate, not because it records a lost survey, but because it perfectly illustrates a powerful, persistent idea. The most profound example of this is the legendary Terra Australis. For over 2,000 years, from ancient Greek philosophers through the Age of Discovery, scholars were convinced a great southern continent must exist. Their reasoning was elegantly symmetrical. They observed that most of the world's known land was clustered in the northern hemisphere. To balance the globe, both physically and metaphysically, a counterweight land of equal or greater size was deemed necessary. This was not a hypothesis born from a sailor's logbook, but from a library, a philosophical need for cosmic equilibrium. As this idea passed from Ptolemy's writings into medieval and Renaissance cartography, it transformed from a theoretical concept into a tangible shape on parchment. Mapmakers, compelled by scholarly tradition, began to draw this southern land, often labeling it Terra Australis Incognita, the unknown southern land. Its size and shape varied wildly from map to map, sometimes a massive continent encircling the South Pole, other times a more modest landmass. The critical point is that its inclusion was an act of intellectual compliance, not cartographic fact. This creates a fascinating illusion of foresight. When later explorers like James Cook finally sailed into the Southern Ocean and encountered the very real continent of Antarctica, it seemed to later historians as if those old mapmakers had known something. In a way, they did. They knew a compelling theory, but the resemblance between their philosophical conjecture and the actual icy landmass is, in many cases, a spectacular coincidence. A scholar of the history of ideas would note that this shows how our mental models of the world actively shape what we expect to find, and sometimes reality reluctantly agrees. This forces a crucial question for every anomalous map we encounter. When we see a southern continent on an old chart, are we looking at the faint echo of transmitted geographical data, or are we seeing the bold outline of a deeply held belief that, by pure chance, later resembled reality? Disentangling these threads requires more than just overlaying coastlines. It demands we step into the mind of the mapmaker. We must ask what sources they cited, what philosophical schools they followed, and what their culture believed the world should look like. The kingdom of Prester John never existed, yet for centuries it was drawn on maps of Asia and later Africa, directing the course of diplomacy and exploration. The magnetic islands that could pull the nails from ships were a feared legend that still informed sailing directions. These elements remind us that every map is a cultural artifact, a portrait of a society's hopes, fears, and intellectual commitments. To interpret them honestly, we must learn to read the mythology in the margins, not as silly superstition, but as a key to understanding the very different logic that once guided the hand that drew the lines. Recognizing this allows us to sift the possible fragments of genuine, anomalous knowledge from the compelling noise of ancient belief. A master map in 16th century Lisbon was worth more than its weight in gold, and knowing its secrets could cost you your life. Within the guarded halls of the Portuguese Casa da India, cartographers worked under a veil of strictest secrecy. Their task was to maintain the Padrão Real, the royal pattern, a continuously updated master chart that synthesized every scrap of geographical intelligence from the empire's expanding voyages. This was not a document for public education. It was the strategic blueprint for global domination, a state secret as vital and protected as any military code. To copy it, or even to disclose its contents, was an act of treason punishable by death. Spain maintained an identical system with its Padrón Real in Seville. This reveals a fundamental truth about the age of discovery. The most precise geographical knowledge was not academic, it was proprietary. It was a weapon and a treasure locked away by the powers that possessed it. Expert historians of this period emphasize that these master maps were living documents. As each captain returned, his logs and sketches were delivered to the cartographers, who would painstakingly incorporate the new data, a corrected coastline here, a newly discovered island there, into the single, authoritative source. This process created a stark divide in the world's geographical understanding. The official, published maps available to the public were often deliberately vague, outdated, or filled with errors to mislead rivals. The real map, the accurate one, existed only in a few secure rooms. Yet, in a world of fierce competition, no secret remains perfectly sealed. This is where our puzzle of unexpected precision finds a compelling, grounded explanation. Espionage was rampant, Venetian agents, desperate to maintain their republic's slipping trade dominance, sought to infiltrate Portuguese chart rooms. Ottoman admirals like Piri Reis actively interrogated captured Spanish pilots and collected their charts as spoils of war. A disgruntled clerk, a bribed official, or a sailor with a keen memory could become a conduit for a leak. Fragments of that closely guarded, cutting-edge data could, and did filter out. They might surface in a private collection in Genoa, be integrated into a composite world map in Constantinople, or be redrawn from memory by a traveler in a Parisian workshop. The result is a map that appears mysteriously precise for its time and place, not because it holds ancient wisdom, but because it contains stolen intelligence. That intriguing coastline on an Ottoman chart might not be a memory from Alexandria, but a smuggled sketch from a Portuguese caravel that sailed it just a decade before. The detailed shape of a continent on an Italian map might represent not a lost civilization survey, but the latest confidential report from a Spanish spy in Seville, rendered by a cartographer who had no idea of its true, secret origin. This perspective reframes the mystery. It suggests that some of the accuracy we find so baffling may simply represent the bleeding edge of contemporary but clandestine geographical science. It was not knowledge from a deep, forgotten past, but knowledge from the fiercely guarded present, illicitly copied and then detached from its source, leaving later generations to wonder how such information could possibly exist. When we look at these maps, we might not be seeing ghosts of Atlantis, but the shadows of state secrets escaped into the wild. A river's name is a story whispered by the land itself. While we marvel at the grand continental shapes on ancient charts, the true proof of intimate knowledge often lies in the smallest script, the handwritten labels for a bay, a mountain pass, or a winding river. This is the domain of toponymy, the study of place names, and it offers a different kind of evidence, one written not in geometry but in language. When a map created by an outsider accurately records the indigenous names for geographic features, it tells a quiet, powerful story of contact, listening, and collaboration. This precision is not about celestial calculations or stolen master charts. It is earned through patient, on-the-ground inquiry, one conversation at a time. Consider the earliest Portuguese charts of the Brazilian coastline. Beyond the rough outline of the land, the maps are densely annotated with names for rivers, capes, and settlements. These are not Portuguese names, but accurate transcriptions of Tupi-Guarani words heard from the people living there. Linguists who study these documents point out that this level of specific, local naming indicates something profound, sustained, and detailed interaction. A passing explorer might note a major river mouth, but to learn and correctly record the names for dozens of tributaries, hills, and villages requires time, trust, and a deliberate effort to understand the local geography through the eyes of those who know it best. This process transforms a map from a distant sketch into a localized guide. It suggests the cartographer or the sailor providing the information sat with community elders, pointed to features, and asked, "What do you call this?" The accurate result on the parchment is a fossilized moment of cross-cultural exchange. This human-scale path to precision is often overshadowed by theories of lost civilizations or advanced technology, yet it may explain a great deal. Think of the Lewis and Clark expedition across North America. Their famous map was not drawn from a high-altitude survey. It was built from countless conversations with Native American guides who provided not just directions but the true names of the rivers and mountains they passed. That map's accuracy was a direct product of collaboration. Similarly, when we see a 16th-century French map of Canada filled with impeccably rendered Algonquin place names, we are likely seeing the legacy of fur traders and missionaries who lived among the communities for years, learning the landscape through shared experience. This toponymic accuracy is hard-won and deeply empirical. It cannot be faked or theoretically deduced, it must be gathered firsthand. It requires humility, a willingness to acknowledge that the people already present hold the key to understanding the land. So when we examine an old map and find a coastline sprinkled with perfectly spelled local names for features that would be invisible from the sea, we are looking at evidence of a different kind of sophistication. It is the sophistication of diplomacy, of careful observation, and of recognizing that the most reliable source for a map is often the collective memory of the people who call that place home. This perspective gently reframes our search for the source of unexpected precision. Perhaps some of the correct shapes on those enigmatic world maps began not with a spy stealing a state secret, but with a trader sharing a meal, a linguist patiently compiling a dictionary, or a curious sailor writing down what he was told, preserving on parchment a world that was already intimately known. The tools of the ancient navigator were not crude guesses, but elegant mechanical solutions to the problems of sea and sky. To understand how accurate maps could emerge, we must step onto the deck of a wooden ship and examine the actual technological toolkit. The most vital instrument was the magnetic compass, a Chinese innovation that reached the Mediterranean by the 12th century. It did not show true north, but it provided a constant, reliable reference direction, transforming navigation from a hazy art into a repeatable science. With a steady bearing, a captain could finally maintain a straight course across open water, and more importantly, he could record that course. This simple device is the foundational reason those intricate webs of room lines could even be drawn on a Portolan chart. For determining latitude, the Northern Hemisphere offered a celestial gift, the North Star. To measure its angle above the horizon, navigators used tools like the camel, a simple wooden rectangle on a string used by Arab sailors, or the more sophisticated cross staff and mariners' astrolabe. By holding the device up to the sky and aligning it with the pole star, a sailor could read his north-south position directly from a scale. In the southern hemisphere, where the pole star was not visible, they learned to use the sun and complex tables to make similar calculations. Speed and distance were measured with a timeless tool called the log line. A crewman would toss a weighted wooden board, the log, off the stern, letting a knotted rope run freely from a reel. By counting how many knots passed through his hands in a measured time, usually tracked with a sandglass, he could estimate the ship's speed in knots, a unit of measure we still use today. To avoid running aground, they used the lead line, a weighted rope marked with depth intervals, often with a cavity of tallow in the base to bring up a sample of the seabed, sand, mud, or shells, providing another clue to their location. This was the core toolkit, limited but profoundly effective. Mastered over a lifetime, these instruments generated the raw data of exploration, bearings, latitudes, estimated distances, and depth soundings, all meticulously recorded in the captain's logbook. The real magic, however, was not in any single device, but in the process that wove this data together, a method called dead reckoning. From a known starting point, the navigator would plot his course based on his compass bearing and estimate the distance traveled from his log line speed and the sandglass. He would then mark his presumed new position on his chart. It was an educated guess, vulnerable to currents, wind drift, and measurement errors. Over a long voyage, these small errors could compound dramatically, leaving a ship dozens of miles from where its captain believed it to be. This is where the collaborative, long-term nature of map-making comes in. One captain's dead reckoning track was a single, flawed line. But when the logs of 10 ships, or 100, sailing the same routes over decades were compiled in a cartographer's workshop, the errors began to cancel out. One ship might be pushed east by a current, another west. By comparing all the tracks, the true median path, the most probable coastline, would emerge from the statistical noise. This is the quiet, cumulative genius behind the precision of the Portolan charts. They were not the product of one perfect voyage, but the refined average of thousands of journeys, a consensus of the sea built over generations. Nautical archaeologists studying these methods confirm that this toolkit, used with relentless discipline, was more than capable of producing the stunning regional accuracy we see in the Mediterranean charts. So the pressing question shifts. We know they had the tools to map a sea. The deeper mystery is whether this same process of accumulation and compilation, stretched over centuries and across oceans, could theoretically have pieced together a map of the world. Could the dead reckoning tracks of unknown explorers sailing forgotten routes have been gathered in some ancient library and synthesized into a global image that later cultures could only copy, but no longer replicate? The tools in their hands were simple, but the collective knowledge they could produce was anything but. The fragility of ancient knowledge hangs on the steady hand of a single copyist. In a quiet monastery scriptorium, centuries before the printing press, the only way to preserve a map was to replicate it by hand, stroke by painstaking stroke. This monk, likely more skilled in scripture than in geography, is our final and most human link in the chain of transmission. His task was not to understand the coastlines he traced, but to faithfully duplicate them. Yet, in that very act of preservation, the map began to change. A quill nib catches on the vellum, subtly rounding a jagged cape. A moment of distraction shifts an island a fraction of an inch. A faded spot on the original parchment is misinterpreted and filled in with a guess. These are not acts of forgery, but the inevitable entropy of manual copying. Every new copy was a generation removed from its parent, each accumulating its own tiny mutations. Over decades and centuries, a precise coastline could soften into a generic curve. A detailed river delta could simplify into a mere fork. This process explains why so many medieval maps feel vague or distorted. They are the echo of an echo, their original clarity lost through generations of well-intentioned replication. The copyist's dilemma was twofold. First, the mechanical challenge of perfect reproduction. Parchment stretches and shrinks with humidity. Ink bleeds. Colors fade, transferring a complex geometric network of lines from one irregular sheet to another, without the aid of tracing paper or a pantograph, was an immense technical feat. A slight error in the initial positioning of a compass rose could throw the entire orientation of a continent off by critical degrees. Paleographers, the scholars who study ancient handwriting and manuscripts, note that these documents must be read not just for what they show, but for the physical story of their creation, the pressure of the pen, the corrections, the patches of reused parchment. The second, more profound dilemma was interpretive. What does a copyist do when the source map contains something that seems obviously wrong? Imagine a monk copying a chart that shows a vast ocean where he knows, from recent travelers' tales, there is now known to be land. Does he copy the old error faithfully, or does he correct the map with the newer information? Often, they chose to correct, to improve, to synthesize. This creates a hybrid document, a palimpsest of time. The map becomes a layered artifact containing both the ancient, possibly accurate skeleton and the contemporary understanding grafted onto it. This is crucial for our mystery. A single surviving map that appears anomalously precise might not be a lone creation, but the one rare, faithful copy from a long lineage of degraded versions. It is the equivalent of a genetic bottleneck, where the purest expression of an original trait survives by chance in one descendant, while all others show the accumulated mutations. The map we can hold and study is just a single leaf on a vast, lost genealogical tree. Its surprising accuracy is not proof that its immediate creator was a genius. but that he was an exceptionally careful librarian, resisting the urge to fix what he did not understand. Meanwhile, his contemporaries, making what they thought were sensible updates, may have inadvertently corrupted the very data they sought to clarify. This transforms our search. We are not looking for a single map, but for a family resemblance across many. When we see a strangely accurate coastline on a chart from 1513, we must ask, is this a brilliant innovation, or is it the quiet, unedited whisper of a much older voice, preserved by a scribe who had the humility to copy what he saw, not what he thought should be there? The coastline on the parchment seems to call out, begging us to see a lost world. This deep human longing to believe in forgotten golden ages and hidden truths is perhaps the most powerful map of all, one drawn not on vellum but within our own mind. From the sunken spires of Atlantis to the star charts of ancient astronaut theories, our culture is saturated with narratives of a grander, more knowledgeable past. This psychological terrain is crucial to navigate if we are to understand these maps with clear eyes. At the heart of this allure is a well-documented cognitive shortcut called confirmation bias. When presented with a complex, centuries-old chart, our attention is magnetically drawn to the single feature that seems impossibly accurate: the shape of a continent, the curve of a bay. We fixate on that one compelling hit, while our gaze slides past the numerous misses, the distorted coastlines, the misplaced islands, the entire sections that are plainly wrong. A historian of science might note that the human brain is a pattern-seeking engine, and it is far more satisfying to discover a grand, hidden order than to accept a messy accumulation of errors, guesses, and lucky coincidences. The mystery itself becomes the prize, and the desire to solve it can sometimes override our disciplined skepticism. This isn't a failing, it's a fundamental part of how we engage with the unknown. It's the same impulse that draws us to a gripping detective story or a puzzle box. The danger arises not from the wonder, but from letting that wonder do all the thinking for us. Recognizing this internal pull makes us more responsible investigators. It allows us to hold two truths in balance. We can stand in genuine awe of the Oronteus Finaeus Map, marveling at its detailed southern continent, while also honestly confronting its many geographical errors and the strong possibility it represents brilliant theoretical guesswork rather than literal survey data. We can be captivated by the Piri Reis map's cryptic notes about ancient sources, while also acknowledging the mainstream scholarship that sees a composite of contemporary, if fragmented, exploration reports. This balanced mindset doesn't diminish the mystery, it deepens it. It shifts the question from a simplistic, did a super-civilization exist, to a far richer and more human series of inquiries. How did knowledge actually travel across the medieval and early modern world? What brilliant workarounds did ancient astronomers and sailors develop that we have yet to fully appreciate? What stories of real, undocumented contact and exchange are still waiting to be uncovered in the archives? By acknowledging our own psychological desire for a neat, spectacular answer, we free ourselves to appreciate the messy, complicated, and ultimately more fascinating reality. The greatest historical artifact these maps offer may not be a depiction of Antarctica without ice, but the enduring human question mark they represent, a testament to our endless curiosity about the world and our place within its long-forgotten story. The glow of a flat-screen monitor now illuminates the same parchment that once lay in an Ottoman admiral's study. In a quiet university laboratory, a cartometrician, a specialist in the mathematical analysis of old maps, is not pondering lost civilizations. Her focus is on a high-resolution digital scan of the Piri Reis map, loaded into a sophisticated geographic information system. This is the new frontier of the mystery, where 21st century technology meets 15th century ink, transforming subjective debate into a field of measurable data. The power of this approach lies in its cold, computational precision. Using GIS software, the researcher can overlay the historical map with a satellite-derived coastline of the modern world, not by eye, but through complex algorithms that calculate the statistical correlation between thousands of data points. This process quantifies accuracy in a way Charles Hapgood could never have imagined, generating metrics that tell us exactly how closely or how poorly the old chart aligns with reality. It moves the discussion from a feeling of eerie resemblance to a hard number. More than just comparison, these digital tools allow experts to reverse engineer the mapmaker's possible methods. The software can model different map projections, testing to see if the chart's distortions match those that would occur if someone tried to flatten a spherical Earth using a specific geometric formula. It can analyze the scale, checking if it remains consistent across the map or varies in telltale ways, suggesting the compilation of multiple source charts drawn at different scales. This digital archaeology can even attempt to computationally disentangle those sources, identifying clusters of coastline that share a common geometric signature, hinting at the separate documents Piri Reis might have stitched together. The result is not a single, definitive answer, but a refined and sharper set of questions. The technology helps separate genuine cartographic head-scratchers from simple coincidences. For instance, an algorithm might reveal that a seemingly accurate stretch of coastline aligns perfectly only when a specific, consistent error in longitudinal placement is applied across the entire section, suggesting a systematic mistake in the source material rather than miraculous foresight. Conversely, it might highlight a section where the alignment is too statistically significant to dismiss as mere luck, even after accounting for all known exploration of the era. This scientific lens does not destroy the mystery, it clarifies it. The future of understanding these maps lies in this marriage of historical inquiry and data science. It is a shift from asking, "Does this look like Antarctica?" to asking, "What precise mathematical fingerprint does this map possess, and what historical processes could have generated that unique pattern?" The tools on the screen offer no easy tales of Atlantis, but they provide something perhaps more valuable, a rigorous method for listening to the faint, geometric whisper of the past, allowing the maps themselves to tell their own story, one coordinate at a time. The digital scan is a starting point, not an end. To truly hear what these ancient maps are whispering, we must invite more voices into the room. The solution to these cartographic puzzles will not be found in a single book or a lone laboratory. It demands a symphony of disciplines, a holistic approach where the historian, the astronomer, the linguist, and the climate scientist all lean over the same parchment, each asking their own unique questions. No single expert holds the key, because a map is not just a drawing. It is a nexus where every strand of human knowledge about our world converges. Imagine a dedicated research project, a kind of grand cartographic inquest. Historians would trace the fragile lineage of the physical document itself, tracking its ownership, its paper, its inks, building a biography of the artifact. Meanwhile, linguists would decode every faded place name, searching for roots in forgotten languages or clues to the identity of the informants who provided them. This is where the human story lives, in the words scribbled in the margins. At the same time, oceanographers and geophysicists would model ancient coastlines, calculating how sea levels have risen or fallen over millennia, revealing which bays might have been accessible to ships in a different climatic era and which headlands have since eroded away. Climatologists could reconstruct prevailing wind patterns and ocean currents from 1,000 years ago, painting a dynamic picture of the sailing routes that would have been fastest, safest, or most likely to sweep a vessel off course into the unknown. This data would tell us not just where a mapmaker could have gone, but where the very winds and waters might have taken him, willingly or not. Computer scientists would then build simulations, feeding all this environmental and historical data into models that test thousands of possible voyage scenarios, seeing which combinations of starting points, navigational errors, and recorded landmarks could realistically produce the shapes we see on the chart. This collaborative framework moves us beyond the tired, polarized debate between so-called alternative history and mainstream skepticism. It replaces the question of who is right with a more productive inquiry: what combination of factors is most likely? It treats each map not as a proof for a single, spectacular theory, but as a complex historical document, a patient that requires a full team of specialists for a proper diagnosis. The goal is no longer to declare a winner in an argument, but to assemble the richest, most nuanced understanding possible from every available fragment of evidence. In this integrated view, the Piri Reis map is no longer just a battleground between Atlantis believers and orthodox historians. It becomes a meeting ground. The astronomer can speak to the accuracy of its latitudinal placements, the linguist to the origins of its Turkish and Arabic annotations, the naval archaeologist to the feasibility of the voyages described in its notes. Each thread, examined with rigor and then woven together, creates a stronger, more colorful tapestry than any single thread could alone. This is the future of the mystery, a shift from solitary speculation to coordinated exploration. It acknowledges that our ancestors' understanding of the world was itself holistic, blending observation of the stars with the feel of the waves, the stories of travelers with the logic of geometry. To meet them on their own terms, we must be willing to think the same way, bridging the artificial divides between our modern specialties. The true lost continent we are searching for may not be a physical landmass, but the lost connection between all the different ways we have of knowing. The implications ripple far beyond the parchment, reaching into the very story we tell about ourselves. If even a small portion of this cartographic precision reflects genuine, transmitted knowledge, then our historical narrative of exploration is not merely incomplete, it is fundamentally reshaped. The question is no longer just about coastlines, but about connections. It suggests a world where the great oceans were not absolute barriers, but highways occasionally traveled, where ideas and goods and maps flowed along routes now erased from memory. This wouldn't demand the existence of a single, mythical super-civilization. Instead, it opens the door to a series of forgotten episodes, voyages by known cultures that ventured farther than our records attest and shared what they found. Historians of exploration often note that our textbook timelines are built on surviving documents, the loudest voices in the archive. But what of the quiet journeys, the ones that left no colonies or chronicles, only a whispered description that eventually found its way onto a chart? Consider the Phoenicians, master sailors of the ancient Mediterranean. The Greek historian Herodotus recounts a tale, dismissed for centuries as fable, of a Phoenician expedition commissioned by an Egyptian pharaoh to sail around Africa. They reportedly set out from the Red Sea and returned through the Pillars of Hercules years later, claiming the sun was on their right hand as they sailed west, a detail that perfectly describes the southern hemisphere. If such a voyage truly occurred, it means a detailed awareness of Africa's full contour could have entered the geographical knowledge of the ancient world, only to be later forgotten or relegated to legend. Similarly, the Polynesian expansion across the Pacific is one of humanity's greatest feats of navigation. The sweet potato, a crop native to South America, was found across Polynesia long before European contact. This is hard, botanical evidence of transoceanic exchange. Could a Polynesian voyage have reached the western coast of the Americas? And could a description of that long, mountainous coastline have traveled back across the ocean and, through a chain of traders and storytellers, eventually influenced a mapmaker in Asia or even Europe? The possibility reframes the pre-Columbian world from a collection of isolated continents into a planet with thin, tenuous, but very real threads of awareness stretching across the waters. Even within the medieval period, we have hints of extraordinary reach. The Norse sagas tell of Vinland, and archaeological proof of their settlement in Newfoundland is now established fact. If the Norse made it to North America, who is to say an intrepid group didn't push farther south, or that their knowledge passed to other seafaring cultures, didn't circulate in a fragmented form? These maps then become potential windows into a more dynamic and interconnected past. They challenge the Eurocentric narrative that frames the age of discovery as a sudden, brilliant light illuminating a dark and unknown world. Instead, they suggest a flickering, intermittent glow that had been present for millennia, a glow that would sometimes flare up when conditions were right, when a curious culture had the ships, the motive, and the courage to sail beyond the horizon. The historical impact is profound. It means that cultural development may not have been a series of independent inventions in isolation, but a slower, more complex tapestry of intermittent contact and shared inspiration. A technological idea, a mathematical concept, or a story about a distant land could hopscotch across the globe over centuries, leaving almost no archaeological trace except for a single, stubbornly accurate line on a map copied by someone who no longer knew its origin. Validating this would not diminish the accomplishments of Columbus or Magellan, but it would place them in a much longer, more ambitious human story. They would become not the first to dream of other shores, but the heirs to a deep and fragmented legacy of exploration, the ones who finally forged the links into a permanent chain. The true discovery, then, might not be of new land, but of our own forgotten curiosity. So we are left with the maps themselves and a silence where the explanation should be. The state of this centuries-old puzzle is both clear and profoundly unresolved. We possess artifacts like the Piri, Reis, and Oronteus Finaeus charts, which contain specific geographical features that startle us with their apparent foresight, particularly those haunting coastlines that resemble a world without ice. Yet, for every compelling alignment, we lack a definitive, smoking gun piece of evidence that irrefutably explains how such knowledge was physically obtained and by whom. The historical record, as we currently understand it, offers no ledger of an ancient admiral who circumnavigated Antarctica, no royal chronicle of a global survey. This absence is the very bedrock of the mystery, creating a space where questions echo louder than answers. Three fundamental inquiries persist, shaping all modern investigation. First, and most tantalizing, what was the ultimate source for those Antarctic-like contours? Was it a literal pre-glacial survey conducted by a culture lost to deep time, its charts preserved as cryptic heirlooms? Or was it a spectacular cartographic coincidence born from theoretical guesswork and the misplacement of other lands? Second, does this suggest the existence of a coordinated, global data compilation in antiquity, perhaps centered in a scholarly hub like Alexandria, where reports from Phoenician, Greek, and other traders were synthesized into a master worldview that later fragmented and dispersed? And third, how much of the precision we see is simply the brilliant final synthesis of 16th century mapmakers, those intellectual magpies in Istanbul and Paris who wove every available thread, stolen Portuguese charts, Arab sailing directions, classical texts, and sailors' rumors, into a tapestry that sometimes by sheer luck mirrored reality? The most satisfying answer likely does not reside in any single spectacular theory. The truth of these maps probably lies in a complex combination of factors, a confluence of streams that flowed together in the Renaissance. Imagine fragments of genuine ancient knowledge, perhaps a star chart with correct longitudes or a weathered Portolan from a forgotten voyage, surviving in some archive. Add to that the feverish, competitive synthesis of the age, where geographers collated every scrap of intelligence with unprecedented zeal. Factor in the underestimated skill of centuries of dead reckoning, where the accumulated tracks of thousands of voyages slowly carved the true shapes of continents into the collective understanding of mariners. And finally, acknowledge the inevitable role of inspired speculation and plain luck, a cartographer's elegant guess about a coastline that, against all odds, later proved true. The mystery endures precisely because it sits at the very edge of our historical evidence, in that dim realm where documents fade into legend and memory distorts into myth. It is tantalizingly out of reach, yet grounded in tangible objects we can hold and study. This elusiveness is not a flaw in the puzzle, but its defining feature. It is what keeps the quest alive and intellectually vital, inviting each new generation to look at these old vellum skins with fresh eyes, to ask new questions with sharper tools. The maps do not give up their secrets easily, and perhaps they never will entirely. But in that enduring silence, they continue to speak, challenging our assumptions and reminding us that the past may be far more curious and far more connected than our textbooks have yet dared to say. The journey across these vellum seas has brought us not to a final port, but to a horizon of deeper questions. We began with a single, stunning anomaly, a coastline on an Ottoman map that seemed to know a continent hidden under miles of ice. From that starting point, we navigated through theories of lost civilizations and scholarly synthesis, past the precise craft of Portolan charts and the celestial wisdom of Polynesian wayfinders. We witnessed how knowledge could be a state secret, a whispered story, or a sacred memory passed down without a single written word. Each explanation, from Hapgood's ancient sea kings to the competitive espionage of rival empires, offered a piece of the puzzle, yet none completely contained the whole picture. The true revelation of this exploration is not a buried city or a single forgotten explorer's log. It is the dawning understanding that our ancestors' relationship with the planet was likely far more dynamic, interconnected, and intellectually ambitious than the clean timelines in our history books suggest. These maps stand as stubborn outliers, refusing to fit neatly into the narrative of linear progress. They hint at episodes of long-distance contact, brilliant cartographic guesswork, and perhaps even moments of profound geographic insight that flickered brightly and then were lost, only to be glimpsed centuries later in a copied document. The key takeaway is a shift in perspective. Instead of demanding a verdict lost civilization, yes or no, we are left with a richer, more humbling appreciation for the complexity of knowledge itself. It flows like water, finding paths through cracks in the historical record, seeping from one culture to another through trade, conquest, or simple curiosity. It can be preserved with monastic care in a library or carried perfectly in the memory of a navigator who never learned to write. These charts challenge the arrogance of the present, reminding us that precision is not the sole property of the digital age. It can emerge from the slow accumulation of countless voyages, from the patient observation of the stars, from the courage to sail beyond the known wind. So where does this leave us? With an invitation, not a conclusion. Let these mysterious coastlines be a call to keep looking, to keep questioning. History is not a closed book but an ongoing investigation, and every generation brings new tools, like digital cartometric analysis, to re-examine the old evidence. Perhaps the greatest legacy of the Piri Reis map, the Oronteus Finaeus chart, and all the others is that they refuse to let us be complacent. They whisper that there are still hidden chapters in the human story, stories of exploration and understanding written in the silent language of latitude and longitude. They remind us that a map is more than a tool. It is a testament to an unbroken, ancient drive to look at the vast, unknown world and say, I will find my place in this. We would love to hear your perspective on these enduring mysteries. Which theory resonates most with you, or do you have another take entirely? Share your thoughts in the comments below, and if you're fascinated by these hidden chapters of our past, subscribe to continue the journey with us. The map, after all, is never truly finished. It is always waiting for the next curious mind to trace its lines and ask, what story have we